Hey everyone, so today's lesson we are trying to find the empirical and the molecular formula of a compound or a grouping of compounds. And what that is it's pretty much just these formulas that we've been naming in previous chapters. We're just trying to figure out how to find that through lab data. So what is an empirical formula and what is a molecular formula? Well, let's do two columns here. I'll put molecular on the left, and I'll put empirical on the right. And molecular formula is just a bunch of groupings of one compound together, and they form this kind of bigger formula, less simplified formula. So let's say that I have this big molecular formula of C5H10O5. So that is the molecular formula. That's the groupings of a bunch of compounds. Well, the empirical formula is just the simplified version of this molecular formula. It's the most basic form. The empirical formula is what we use to give the formulas of our compounds that we are naming. So the most simplified formula of this, right, it's C5H10O5. If we reduce that as much as we can, the empirical formula will be CH2O. So that's all it is. So the empirical formula is just one CH2O, while the molecular formula is 5 CH2Os all grouped together. So empirical formula is just the smaller version, while molecular formula is the larger version. Let's do another one. Let's look at C6H12O6. That's my molecular formula. Well, once again, I'm just going to reduce that, right? All these numbers are reducible by 6, and it is now, once again, CH2O. So again, this is just where we added one more CH2O molecule, and it made this nice molecular formula of C6H12O6. So again, longer version, simplified version. What if we're looking at H4O2? What's the empirical formula of that going to be? Well, we could reduce those by 2, right? So it's just going to become H2O. So here I have the most simplified version, the empirical formula, while here I just have two H2Os, which is the molecular formula. Let's do another one. Let's do CO2. The molecular formula is CO2. And you might be saying, Mr. Dahmer, we can't reduce this anymore. That's because you're right, okay? We can't reduce this anymore. So the empirical formula is just the exact same, okay? There are situations where the molecular formula and the empirical formula can be the exact same. So, again, that is pretty much our foundation of molecular and empirical formula. Molecular is the bigger version. You have a bunch of molecules together. That's why it's called molecular. And empirical is just the most simplified form of that molecular formula, okay? So, how are we going to find these? Well, first, we're going to figure out how to find the empirical formula. And I'm going to pause this, put some rules on the board, and then you can start to write those down. All right, everybody. So up here, I have 4 steps for finding EF, or empirical formula. That's what we're focusing on first, that most simplified version of our chemical formula. And I have 4 rules here that I want you to write down. They might not make sense now, but they will once we go through our first example. So we want to change percents to grams. Step 2, we want to turn grams to moles, which you should know from our chemical quantities lesson. Divide by smallest mole, which I'll explain in a bit. And then make numbers whole if necessary, which again will make sense when we get through this example. But let's go ahead and do an example to apply to these rules, okay? And I'm going to do it in my small amount of space over here. Say that I have this chemical in a lab and I've analyzed it through some sort of instrumentation, and I have told you that this chemical is 75.46% carbon, it is 4.43% hydrogen, and it is 20.16% oxygen. I know I ran out of room there, but we have 75.46% carbon, 4.43% hydrogen, and 20.16% oxygen. Okay? So I have these percentages here that I've analyzed this compound in the lab, and what I want to do is I want to turn these percents into grams. So that's what I'm going to do. I'm just going to say, instead of having 75.46% carbon, I have 75.46 grams of carbon. Same with the hydrogen. I'm going to say that I have 4.43 grams of hydrogen. And same with oxygen. I'm just going to say I have 20.16 grams of oxygen. So step 1 is complete. Okay? So that's it. We just treat it like it's a 100-gram sample of our compound, and we change all those percents to grams. Next up, I need to turn grams into moles. Okay? And we should know how to do that, right? We just divide by the molar mass of all of our elements. So, carbon's molar mass is 12, so we're going to divide by 12 grams per mole. Hydrogen will divide by 1 gram per mole, because that's the molar mass of hydrogen. And oxygen will divide by 16 grams per mole. And now we should calculate all these out, and we should get our moles of each compound. I got 75.46 divided by 12. That gives me 6.29 moles of carbon. 4.43 grams divided by 1 gram per mole. We should know that in our head. That's 4.43 moles of hydrogen. And our last one there, 20.16 divided by 16. That gives us 1.26 moles of oxygen. So now I got my moles of carbon, hydrogen, oxygen. So now step 2 is done. Now what we do is step 3. We divide by the smallest mole number, or the smallest mole that we have. Well, out of our 3 moles, the smallest one that we have is 1.26. So that means we're going to divide each of our moles by 1.26. That's what I mean by divide by the smallest mole number. I look at which one's my smallest, and I divide all the moles by the smallest amount of moles, which is 1.26. So I'll divide 1.26 by 1.26. I'll divide 4.43 by 1.26. And I'll divide 6.29 by 1.26. And I should get 3 numbers here. We know this one's going to be 1, and that'll be 1 oxygen. I'll take 4.43 divided by 1.26, and I'll get somewhere around 3.5. Okay, let me erase that so it kind of reflects the 1 a little bit better. And then I'll take 6.29 divided by 1.26, and I'll get somewhere pretty dang close to 5. Alright, so I got 5, 3.5, and 1. Well, step 3 is now done. But now my last step. I need to make the numbers whole if necessary. So I have numbers 5, 3.5, and 1. Those are not all whole, right? 3.5 is a decimal number. It's 3.5. And I need to make those whole. So in order to make those whole, I'm just going to multiply all my numbers by 2. I can't just round this up to 4, okay? I have to multiply all my numbers by 2. So now this 5 is going to become a 10, because 5 times 2 is 10. 3.5 is going to become a 7. And 1 is going to become a 2. And now I have completed step 4. So now I've just gone through all those steps, and I have came up with the numbers 10, 7, and 2. What does that mean? Well, that tells you how many atoms of each element are in your empirical formula. So from carbon, we ended up with the number 10. So that means in our empirical formula, we have 10 carbons. From hydrogen, we got the number 7. So that means in our empirical formula, we're going to have 7 hydrogens. And then as you can see, from oxygen, we obtain the number 2. So that means we're going to have 2 oxygens. And that is how you find empirical formula. It's long, it's drawn out, but it's pretty simple once you get some practice with it, okay? So again, we're following these 4 steps. We're going to go ahead and we're going to do another example here, and then we'll eventually get into molecular formula. All right, everyone. Here's another problem where I have been given percentages and it says find empirical formula. And just a heads up, sometimes I won't even give you percentages and I'll just give you grams right off the bat. Well, if I give you grams right off the bat, you pretty much just get to skip step 1 because they're already in something that you could change to moles. But as for this one, I want to find empirical formula and I've given you percentages. So my first step is I got to change those to grams, which again is just simply getting rid of that percent sign and putting grams instead. So I got 50.05 grams of sulfur and I got 49.95 grams of oxygen. Again, we get those numbers by putting in some sort of instrumentation device. We might have a little white powder that we don't know what it is. We throw it in a machine and it tells us it's 50.05% sulfur and 49.95% oxygen. So anyway, step 1 is done. Step 2, remember we got to change these grams to moles here. So I'm looking on my periodic table for my molar masses of sulfur and oxygen. Sulfur is 32 grams per mole, while oxygen is 16 grams per mole. I'm going to divide by those molar masses to go ahead and get moles. So I'm going to take 50.05 divided by 32 and I get 1.56 essentially moles of sulfur. I'm going to take 49.95 divided by 16 and get somewhere around 3.12 moles of oxygen. Now step 2 is done and I'm moving on to step 3, which if you remember, step 3 is we divide by the smallest amount of moles, which in this case is 1.56. So I'm going to divide both of these moles by the smallest mole, which is 1.56. And I should get 1 for this guy. And I should get 2 for this guy. 1 and 2. Now step 4, make the numbers whole. They're already whole. I don't have to do anything else. Step 4 I can skip because it is not necessary because both of my last numbers are whole numbers. And now I could go ahead and come up with my empirical formula. This tells me I have 1 S in my empirical formula and 2 oxygens. That is my empirical formula. Alright, so let's go ahead and now talk about how we get to find molecular formula. Alright everybody, so here I want you to find the molecular formula now for CH2. If the molecular formula molar mass is 28.1 grams per mole. Now here I have just given you the most simplified empirical formula. Sometimes I'll give you percentages and I'll say find the empirical formula on your own and then solve for the molecular formula. So here we've just skipped those first 4 steps that we do. I've given you empirical formula. Now let's figure out that molecular formula. So again, molecular formula is a non-simplified version of our empirical formula. It's multiple empirical formulas stacked together. And we got to figure out just how many of those empirical formulas are going to be involved in our molecular formula. So what they have done is they have given us the molar mass of our molecular formula. It's told us the whole weight of all those compounds together. So all we have to do is we just take that molecular formula that they give us of 28.1 and we divide it by the molar mass of our empirical formula. Okay? So they gave us the whole molecular formula of 28.1 grams per mole. Now the empirical formula, molar mass, right, of CH2 is 1 carbon, which is 12, and 2 hydrogens. So the molar mass of CH2 is 14 grams per mole. So again, all I'm doing is I'm taking that molecular mass and dividing it by the empirical formula, molar mass. They will always give you that top number. They will always give you the molecular formula molar mass. There's no way you can find molecular formula unless they give you the molecular formula molar mass. And you'll just have to find this guy by finding the molar mass of our empirical formula. So we take 28.1 divided by 14 and you get a number of 2. Well, what does that number 2 mean? That tells you how many CH2s there are in the molecular formula. So all you have to do is take 2 times CH2, and that means you're going to have a molecular formula now of C2H4. Alright, so all you're doing is taking that molecular molar mass they give you, dividing it by the molar mass of the empirical formula, and it will give you a whole number in which you multiply the empirical formula by. And then that gives you your molecular formula. Let's go ahead and do an example where we have to find the empirical formula, and then after all that, we have to find the molecular formula as well. Alright everybody, this is our last example. So right now I've given you grams of carbon, grams of hydrogen, gram of oxygen, and I'm telling you that it has a molecular mass of 90.0 grams per mole. And all I want you to do is find the empirical formula and the molecular formula. So we can't find the molecular formula unless we have an empirical formula to help us out. So we need to figure out that empirical formula first, which is those first 4 steps that we were talking about. So let's go ahead and do that. Step 1, change percentages to grams. Well, I already did a little bit of that work for you. They're already in grams, so we can't really change percentages to grams here. So in this case, we get to skip step 1. So we're just going to move right on to step 2, which is change these grams to moles. So let's go ahead and let's do that. We got 6.99 grams of carbon. We're going to divide by 12 grams per mole, or its molar mass, to get moles. We're going to take 1.17 grams of hydrogen and divide it by its molar mass to get moles. And we're going to take 9.31 grams of oxygen and divide it by its molar mass of 16 to get moles. Now I'm going to go ahead and plug in this first one into the calculator. 6.99 divided by 12 is 0.5825 moles of carbon. I don't need a calculator for this one because I went to college. Okay. Moles of hydrogen. And then that last one, 9.31 divided by 16, gives me moles of 0.5819 moles of oxygen, which is pretty dang close to this one. So we're probably going to have a 1-to-1 ratio there. Step 2 is done. I've gotten all these to moles. And step 3, divide by the smallest amount of moles, which is either one of these are pretty dang close, but we'll go with the actual smallest one, which is 0.5819. Divide by 0.5819. Divide by 0.5819. I can tell you that these two on both ends are going to be 1, but let me just double check. 1.17 divided by 0.5819. That's pretty dang close to 2. Okay? All these are whole numbers. I don't have to multiply it by 2 because they're all whole. I could skip step 4. So my empirical formula, my most simplified formula, is C1H2O1. So there is my empirical formula. I got part 1 done. But now I need to go ahead and I gotta figure out my molecular formula. So to do that, remember, we have to take that molecular mass that they're always going to give us and divide it by the molar mass of our empirical formula. That'll tell us how many empirical formulas are in our molecular formula. So the molar mass of this is 12 plus 1 for each hydrogen plus 16, which gives us an empirical formula molar mass of 30 grams per mole. So now what I do is I take my molecular formula molar mass divided by my empirical formula molar mass. And I'm going to erase some of this so I have some more space. So I'm going to take 90.0 grams per mole divided by my empirical formula molar mass. And that's going to tell me that I have to have 3 empirical formulas in my molecular formula. So I'm going to take that 3 times it by CH2O2. Make that a little bit bolder. 3 times C is C3. 3 times H2 is H6. And 3 times O is O3. So that is our molecular formula. Okay, again, we took our molecular molar mass divided by our empirical formula molar mass, and that told us how many empirical formulas are going to be in our molecular formula. So that's it, guys. That's empirical formula, molecular formula. Lots of steps, but it's not bad once you do a couple of these, okay? So that's it. Try out the practice. Let me know if you have any questions, and have yourselves a great day.